This lecture is going to be over section 25.1. This particular chapter is dealing with optical instruments. And so what we're going to look at here is each of these types of images or methods of imaging and kind of get a picture for how they work. No pun intended. For 25.1, we're looking at the camera. So a camera forms a real inverted, usually reduced image of the object being photographed. So for cameras that use film, the amount of light striking the film is controlled by the shutter speed as well as the aperture. So you can see here you've got the object, and then as it comes in, the object is turned upside down, and then you have an inverted real image. So let's go and let's take a look here. All right, so we've got essential elements of the camera. It's going to be the lens, as you might imagine, and it's equipped with a shutter, as well as a light-tight enclosure to control the amount of light that's coming in, and then light-sensitive film or electronic sensor. That's going to record an image, and so the image forms an inverted, usually reduced, real image in the plane of the film or sensor or of the object being photographed. So in order to provide the proper image distances for various objects, the lens is moved closer to or farther from the film or the sensor, often by being turned in a somewhat threaded amount or threaded mount, just like you see the threads on a screw. It's the same type of deal here. Most lenses are going to have several optical components, permitting partial correction of various aberrations, including the dependence of the index of refraction on wavelength and limitations imposed by the paraxial approximation. So you can see all the components that are coming through here. You've got the object and then the aperture control diaphragm, the lens, and then you've got the shutter. And then as these two cross in, you can see the rays cross and put an image together that is upside down. So in order for the film or the sensor to record the image properly, the total light energy per unit area reaching the film or the exposure must fall within certain limits, and the shutter and the lens aperture help with this. The shutter controls the time interval during which the light enters the lens, and the interval is usually adjustable in steps corresponding to factors of about 2, often from 1 second to 1/1000th of a second. So the intensity of the light that reaches the film is proportional to the effective area of the lens, which may be varied by means of an adjustable aperture or diaphragm, a nearly circular hole with a variable diameter. The aperture size is usually described as a fraction of the focal length of the lens. A lens with a focal length of 50 millimeters and an aperture diameter of 25 millimeters has an aperture of f divided by 2. And many photographers call this an f number of 2 or simply f2. So in general, the f with the number is going to be the focal length divided by the aperture diameter. And so because the light intensity at the film or sensor is proportional to the area of the lens aperture and thus to the square of the diameter, changing the diameter by a factor of the square root of 2 changes the intensity by a factor of 2. So adjustable apertures or f-stops usually have scales labeled with successive numbers related by factors of approximately the square root of 2, which you can kind of see here. And so the larger numbers represent smaller apertures. Decreasing the aperture diameter reduces the intensity of light that reaches the film, as you might imagine. Each step of the aperture control corresponds to a factor of 2 change in intensity. The actual exposure is proportional to both the aperture area and the time of exposure. So you're changing the diameter by a factor of 2, changes the intensity by a factor of 4. So you've got some things here that you can kind of read through and kind of work the examples here. So in a digital camera, the light sensitive film is obviously replaced by an array of tiny photocells fabricated onto a semiconductor chip called a charge coupled device, or a CCD. This device covers the image plane, dividing it into many rectangular areas called pixels. Somewhere between 2 to 10 pixels will be on these CCDs chips. And a 2 megapixel camera has about 2 million pixels. So the intensity of light of each primary color striking each pixel is recorded and stored digitally. Once stored, the image can be processed digitally to crop or enhance it, change the color balance, and so on. So that's a neat little section there regarding the camera and what it's used for.